Hi guys, welcome back to Nerd Talk. I am really excited to have you here. So sit back, relax, and get ready for our 16th journey together. In this video, we will journey into the darkest and most mysterious objects in the universe, black holes. We will explore how giant stars die and collapse into cosmic monsters powerful enough to trap light itself. We'll uncover the science behind event horizons, singularities, time dilation, and the terrifying process of spaghettification. From stellar black holes to supermassive giants like Sagittarius A at the center of the Milky Way, we'll discover how these invisible objects shape entire galaxies and challenge the very laws of physics. We'll also dive into accretion disks, relativistic jets, Einstein's theory of spacetime, and humanity's first real image of a black hole. This is a journey to the edge of reality itself, where gravity becomes infinite, time slows down, and the universe hides some of its greatest secrets.
The silent universe.
For most of human history, the night sky looked peaceful. Ancient civilizations looked upward and saw glowing stars decorating the heavens like tiny fires in an endless ocean of darkness. The universe appeared calm, eternal, almost comforting. But the deeper humanity looked into space, the stranger reality became. Beyond the beauty of galaxies and nebulae lies something terrifying. Invisible regions where gravity becomes so powerful that reality itself begins to break apart. Places where time slows down, where light disappears forever, where the known laws of physics collapse into mystery. These objects are called black holes, and they are among the most extreme things ever discovered. Some black holes were born from dying stars. Others became monsters billions of times heavier than our sun, hiding silently at the centers of galaxies, including our own. At first glance, space may seem empty and quiet, but hidden within that darkness are cosmic predators, powerful enough to bend the fabric of the universe itself. And humanity is only beginning to understand them. The monster that cannot be seen. Imagine traveling through deep space aboard a spacecraft. Stars shine quietly around you. Distant galaxies glow across the darkness. Then suddenly, the stars ahead begin disappearing. Not because something blocks them, but because space itself is bending. Light curves unnaturally around an invisible object. The closer you move toward it, the stranger reality becomes. Time slows. Gravity intensifies. Even the paths of nearby stars begin warping. Ahead lies one of the universe's greatest monsters, a black hole. Despite the name, a black hole is not an empty hole floating through space. It is an object created when enormous amounts of matter collapse into an unbelievably tiny region. Its gravity becomes so powerful that nothing can escape once it crosses a certain boundary. Not planets, not spacecraft, not even light itself. What exactly is a black hole? To understand black holes, we must first understand gravity. Gravity is the force that shapes the universe. It keeps planets orbiting stars, it binds galaxies together, and it controls the life and death of stars themselves. Normally, gravity is relatively weak, but when enormous amounts of mass are compressed into a tiny space, gravity becomes unimaginably powerful. A black hole forms when matter becomes packed so densely that escape becomes impossible. If Earth were compressed to roughly the same amount, but all that matter would be squeezed into an incredibly tiny point, creating gravity strong enough to trap light itself. According to Albert Einstein, gravity is not just a force pulling objects together. Mass actually bends space and time around it. Black holes bend space-time more violently than anything else known in the universe. They are regions where the structure of reality itself becomes distorted. The birth of giant stars. Every black hole begins its life as a star, but not an ordinary star like our sun. To create a black hole, nature requires something far larger, massive stars, dozens of times heavier than the sun itself. These giant stars are born inside enormous clouds of gas and dust called nebulae. Over millions of years, gravity slowly pulls hydrogen atoms together. As the cloud collapses inward, pressure and temperature rise dramatically. Eventually, the core becomes so hot that nuclear fusion ignites. A star is born. Fusion acts like a giant engine inside the star. Hydrogen atoms collide and merge into helium, releasing tremendous amounts of energy. This energy pushes outward while gravity pulls inward. For millions of years, these two forces remain perfectly balanced, a cosmic battle between collapse and explosion. The beginning of collapse. Inside the core of a massive star, fusion continues, creating heavier and heavier elements. Hydrogen becomes helium, helium becomes carbon, then oxygen, neon, silicon, and eventually, iron. Iron changes everything. Unlike other fusion reactions, iron does not release energy when fused. The moment the core becomes filled with iron, the star begins losing its battle against gravity. The outward pressure weakens. Gravity starts crushing the core inward at incredible speeds. Within seconds, the balance keeping the star alive collapses completely. The core rapidly compresses under its own unimaginable weight. Temperatures rise into billions of degrees. Atoms begin breaking apart, and the giant star enters the final moments of its life. The supernova explosion? The collapse of the giant star happens unbelievably fast. Gravity crushes the core inward at millions of kilometers per hour. Temperatures rise beyond imagination. Pressure becomes so extreme that atoms themselves begin breaking apart. Electrons and protons collide violently, forming an ultra-dense neutron core. For a brief moment, the collapsing star becomes a cosmic pressure cooker ready to explode. Then, suddenly, the outer layers of the star slam into the dense core and rebound outward violently. The universe erupts. A supernova explosion tears through space with unimaginable force. For a few moments, this dying star shines brighter than entire galaxies containing billions of stars. Shockwaves race across the cosmos. Radiation floods space. The explosion becomes one of the most violent events in existence. But the explosion does more than destroy. It creates. Inside the chaos of the supernova, heavy elements are forged. Gold, uranium, calcium, iron. The atoms inside human bodies were once created inside exploding stars like these. In a very real sense, we are made from ancient cosmic explosions. Birth of a black hole. After the explosion fades, something terrifying remains. The outer layers of the star are gone, but deep at the center, the core continues collapsing inward under its own gravity. Matter becomes compressed beyond imagination. A mountain's worth of mass could fit into something smaller than a city. Gravity grows stronger every second. The pressure becomes so extreme that normal matter can no longer survive. Atoms collapse. The structure of matter itself begins failing. And if enough mass remains, nothing can stop the collapse anymore. Not energy, not pressure, not even the forces inside atomic nuclei. The star disappears into darkness forever. A black hole is born. What remains is no longer truly a star. It becomes a region where gravity dominates completely, a place where escape becomes impossible, a place where the universe itself bends inward. The birth of a black hole marks the transformation of a dying star into one of the most dangerous objects in existence. The event horizon. Every black hole is surrounded by an invisible boundary called the event horizon. This is the point of no return. To escape Earth's gravity, a rocket must travel over 11 kilometers per second. But near a black hole, escape velocity becomes greater than the speed of light itself. And because nothing can move faster than light, nothing escapes. Not planets, not spacecraft, not even photons. Anything crossing the event horizon disappears forever from the observable universe. To an outside observer, objects falling toward the horizon appear to slow down endlessly. Their clocks tick slower, their movements freeze. Time itself begins behaving strangely near the black hole. But for the object falling inward, time feels completely normal. It crosses the horizon without even noticing the exact moment. Beyond that invisible boundary lies a region from which no information can ever return. The universe hides whatever happens next behind the curtain of the event horizon. The no escape zone. Black holes are often imagined as giant cosmic vacuum cleaners, but that is not entirely true. If our sun magically became a black hole, Earth would continue orbiting almost normally, because gravity depends on mass, not darkness. The real danger begins only when something gets too close. Near the black hole, gravity increases dramatically over short distances. This difference in gravitational pull is called a tidal force. The closer you move toward the center, the stronger the pull becomes. Eventually, escape becomes impossible. Not because the black hole actively pulls everything inward, but because space-time itself curves inward so steeply that all possible paths lead deeper into darkness. Inside the no escape zone, every direction points toward the center. Moving away becomes as impossible as traveling backward in time. The black hole does not merely trap matter, it traps destiny itself. Spaghettification. Imagine falling feet first toward a black hole. At first, nothing seems unusual. But gravity near a black hole changes extremely quickly across short distances. Your feet experience stronger gravity than your head. This difference begins pulling your body apart. The closer you get, the stronger the stretching becomes. Your body becomes longer, thinner, more distorted. Eventually, gravity tears apart muscles, bones, cells, and even atoms themselves. Scientists call this horrifying process spaghettification, because objects become stretched into long, thin strands like spaghetti. Near smaller black holes, spaghettification could happen before crossing the event horizon. But near supermassive black holes, the process might begin much later. Either way, once gravity takes control completely, survival becomes impossible. The black hole consumes everything, even the structure of matter itself. Time slows near a black hole. Black holes do something even stranger than trapping light. They bend time itself. According to Albert Einstein, gravity and time are deeply connected. The stronger gravity becomes, the slower time moves. On Earth, this effect is tiny, but near a black hole, it becomes extreme. Imagine orbiting close to a black hole for only a few hours. When you finally return to Earth, years or even decades might have passed. For you, time felt normal, but for the rest of the universe, time moved much faster. Near a black hole, the flow of time itself becomes distorted. The closer you approach the event horizon, the slower your clock ticks compared to distant observers. To someone watching from far away, you would appear to slow down near the event horizon, almost infinitely. Your movements would freeze. Your image would fade slowly into darkness. A black hole is not just a prison of gravity, it is also a prison of time. Einstein's warped universe. Before Einstein, scientists imagined gravity as an invisible force pulling objects together. But Einstein revealed something revolutionary. Space and time are connected into a single structure called spacetime. Mass bends this structure, and gravity is simply objects moving through those curves. A small object like Earth creates only a gentle curve. The Sun creates a much deeper one. But black holes warp spacetime beyond imagination. Near them, space curves so steeply that every possible path leads inward. Even light follows the curve. That is why black holes appear black. The light itself cannot escape the distorted geometry of spacetime. Einstein's equations predicted black holes long before humanity discovered them. But the universe proved otherwise. Reality turned out to be stranger than imagination. The singularity. At the center of every black hole lies something deeply mysterious: the singularity. According to current physics, this is the point where collapsing matter becomes infinitely dense, a place where space-time curves infinitely inward, a place where known physics completely breaks down. Inside the singularity, our equations stop working. Gravity becomes infinite. Density becomes infinite. The laws of relativity and quantum mechanics begin contradicting each other. Humanity's greatest scientific theories fail to explain what truly happens there. Some scientists believe singularities may not truly exist. Others think they hide new forms of physics humanity has not discovered yet. Black holes may contain clues to quantum gravity, or perhaps secrets about the origin of the universe itself. At the singularity, the edge of the black hole becomes the edge of human knowledge. Beyond the event horizon. What truly happens after crossing the event horizon? No one knows. Because no information can escape from inside a black hole, humanity cannot directly observe what lies beyond. The universe hides the answer completely. Some theories suggest matter is crushed forever into the singularity. Others propose something far stranger: wormholes connecting distant regions of space, gateways to other universes, or tunnels through space-time itself. While these ideas remain theoretical, black holes force scientists to ask profound questions about reality. Black holes stand at the boundary between two great pillars of physics: relativity and quantum mechanics. Understanding what happens inside them may someday lead humanity toward a final theory explaining the universe itself. Can we actually see a black hole? Black holes do not emit light. So how did humanity discover them? The answer lies in the chaos surrounding them. Matter falling toward a black hole does not disappear immediately. Instead, it spirals inward at enormous speeds. As this matter collides and compresses, friction heats it to millions of degrees. The gas begins glowing intensely, creating a bright structure called an accretion disk. These disks can become brighter than entire star systems. Even though the black hole itself remains invisible, the surrounding chaos reveals its presence. Humanity learned to see darkness by observing destruction. In 2019, scientists revealed the first real image of a black hole using the Event Horizon Telescope. For the first time in history, humanity observed the glowing shadow surrounding a black hole directly, a blurred ring of fire surrounding darkness, the edge of the abyss, captured by human intelligence.
The accretion disk.
Around many black holes exists one of the brightest structures in the universe, the accretion disk. As gas, dust, and shattered matter spiral inward, they begin orbiting the black hole at incredible speeds. Millions of degrees, hotter than the surfaces of many stars. The closer matter moves toward the event horizon, the faster it travels. Some particles orbit near the speed of light itself. The disk glows with intense radiation, X-rays, gamma rays, and enormous bursts of energy. From billions of kilometers away, astronomers can detect these violent emissions. The invisible black hole announces its existence through destruction.
Matter inside the disk experiences unimaginable conditions. Temperatures hotter than stars, magnetic fields stronger than anything on Earth, gravity powerful enough to warp time itself. The accretion disk becomes a cosmic furnace surrounding absolute darkness.
Jets from black holes. Ironically, black holes are not only destroyers. Some become engines of incredible energy. Around spinning black holes, magnetic fields twist violently through the accretion disk. These fields can launch enormous jets of plasma outward into space. These relativistic jets travel near the speed of light. They can stretch for thousands or even millions of light years across space. Entire galaxies may be shaped by them. The black hole consumes matter inward while simultaneously blasting energy outward across the cosmos. Even today, scientists continue studying how these jets form. Black holes remain mysterious machines capable of producing some of the most energetic phenomena in the entire universe. Objects born from darkness, creating rivers of light.
Types of black holes.
Not all black holes are the same. Scientists classify them into different categories based on their size and origin. The smallest are stellar black holes, formed from collapsing massive stars. These usually contain a few times the mass of our Sun. Larger and more mysterious are intermediate black holes. Scientists believe these objects may form when smaller black holes merge together repeatedly. And then come the giants, supermassive black holes, monsters containing millions or billions of solar masses. Some theories even predict primordial black holes, ancient objects possibly formed moments after the Big Bang itself. If they exist, they may help explain mysteries such as dark matter. Black holes come in many forms, but all of them bend reality to extremes. Supermassive black holes. At the center of nearly every large galaxy lies a supermassive black hole, including our own Milky Way. These cosmic giants can contain millions or even billions of times the mass of the Sun. Yet their origin remains one of astronomy's greatest mysteries. Scientists still debate how these monsters became so enormous. Did they slowly grow by consuming matter over billions of years? Or were giant black holes born early in the universe itself? Some formed less than 1 billion years after the Big Bang, far too quickly for current theories to fully explain. These giants influence entire galaxies. Their gravity affects star formation, galactic motion, and enormous regions of surrounding space. The hidden heart of many galaxies is not a star, but darkness. Sagittarius A star and the edge of knowledge. At the center of the Milky Way lies Sagittarius A star, our galaxy's supermassive black hole. It contains roughly 4 million times the mass of the Sun. Yet from Earth, it appears incredibly small in the sky, smaller than a donut seen on the Moon. Astronomers discovered it by tracking stars orbiting an invisible object at incredible speeds. Only something enormously massive and completely dark could explain their motion. Humanity uncovered the hidden heart of our galaxy and found darkness waiting there.
Black holes are more than cosmic objects. They are laboratories of extreme physics, places where gravity, time, quantum mechanics, and space-time collide. Every discovery about them reshapes humanity's understanding of reality itself. And somewhere within that darkness may lie answers about the origin of the universe or realities beyond human imagination. The story of black holes has only just begun.
Thanks a lot for watching, and if you are liking the videos, please do like, share, and subscribe.